Hello and welcome to our webinar on using HyperWorks for making design changes directly on the FE mesh of a model. We're going to be exploring today tools. One is the cut tool, where we cut a hole in the existing mesh and HyperMesh automatically remeshes that around that hole. We're going to be looking at replicate function, where you can take an existing feature within a mesh and replicate it to other parts of that mesh. And finally, we're going to look at the rebuild tool, which allows you to rebuild a mesh based on meshing criteria without using the auto mesh panel. For our webinar today, we're going to be using this NIAR fuselage model, which we have done some previous analysis with, and we're going to look at that analysis result just now, because we want to use it as a basis for our design changes. So I'm just going to create a second window here within this session and change it from HyperMesh to HyperView and load in some analysis results. So this is our results set here. And we have 4 inertia load cases in this model, an aero pressure case and a modal case. And we're going to make a derived subcase out of these 4 inertia load cases here. So we use a shift key and we select all 4 cases. And we right click and create derived load case. And we're going to have a linear superposition load case from those 4 cases. Under the menu of derived load cases here, we're going to rename it to something simple for the purposes of this demonstration here. We're going to apply some scale factors to each of the directions here. We're going to have 2.5 G in X. We're going to have 1.5 rolling G, 2 G in Y, and 3.5 G in Z. And we're going to right click and make that derived load case now our current load case. And then we want to plot some results on that derived load case. We're going to simply look at sine von Mises stress for the purposes of today. So this is the sine von Mises stress plot for that derived load case. We're going to change our legend here so that we can see some of the stresses a little bit more clearly. What we're actually going to look at is use a hotspot finder to have a look at some of the hotspots around this model. We're going to maximize this window just so that we focus on this model. I'm just going to take off these RBEs here. Now with the hotspot finder tool here, we have some options here under this icon here that allow us to set some criteria for exploring the hotspots around the model. You can change the value filter here to be greater than, less than, within a range. You set your value. We're going to set a value here of 250 megapascals. You can choose a number of results, hotspot results that you want HyperView to look for. And you can choose which load case you want to do it on. The current, we're going to use current simulation for this, but you can choose all simulations, all subcases if you wish. There are some advanced settings as well for that, which control the output options for the hotspot. And we're going to click on Find Hotspot, and HyperView automatically finds 4 hotspots within our settings here, and we're going to click the Review button here. And HyperView will reset the view orientation and create some notes for the top 4 hotspots within our derived load case. We have the setting here set to global model, and that makes it slightly difficult to visualize where those hotspots are. So we're going to change the visualization here down to component level, and we're going to use component transparency What will that do is it will set all the other components to transparent except for the component which the hotspot was found in. And we can zoom in then on that and have a look at where that hotspot is. And we can see that it's on this cross member here. And then we use these arrow buttons here to scroll through where the other hotspots are, the other 4 hotspots that Hyperview found. We have another one on this aft cross member here. We have a third one at the rear bulkhead, right in the tail fin here. And then we have a final one here on some 4 aft cross members supporting in the engine bay here. So we're going to focus first of all on that first one here, this forward cross member here. And actually what I'm interested in now is I'm not so much interested in the hotspot. I actually want to look at this area of low stress here because I perceive that to be an area where I would be able to put some lightning holes in that member and not considerably deteriorate the stress state in that. And that's what I want to demonstrate now with the cut hole function in HyperMesh. So we're going to go back to our 2 view window. I'm going to synchronize these windows. And I'm going to create a section cut in this HyperView window just so that I can see the cross member clearly together with the HyperMesh window. So we're going to flick back to the HyperMesh window. And I want to zoom in on this member here where the hotspot is. I'm going to isolate it by selecting it with the left mouse button and then pressing I. And so what I want to do now is I want to create a hole in this top face of this cross member, roughly where the low stresses are in this result plot on the right. So we're going to select the cut hole option here, and that brings up this menu here. And the first thing we need to do is select the elements that we want to cut. If you hold down the Alt key and mouse over on the face where the elements are, and then left mouse click, you will select all the elements on that face. It's just a kind of quick tool there to help you select elements by face. And then we're going to choose from this list of different options here of holes, we're going to choose a slot from here. And then from there, we simply need to draw our slot on our mesh, roughly where the low stress regions are. We can choose some of the dimensions of that. So perhaps we want a 15 mil radius or even a 20 mil radius on that, on both ends. And then we may also want to move that slot so that it's more in the center of the face. And then once we're happy with where the slot is positioned and the size and dimensions of the slot, perhaps we'll make this 450 here. Then we simply say add slot. And now that geometry that you've just drawn there is now associated with that face of that cross member. And so we simply ask HyperMesh to cut a hole in that top face using that slot. And it will cut a hole in the mesh and remesh it using the meshing criteria that you set for the particular session, and get a hole in that slot, in that face. Just going back to our results for a second or two here, I just want to quickly look at some model results. relating to the modal load case that we have analyzed. So we're just going to turn off the section cut. And we're going to change the load case from that derived load case that we created to this modal load case. I'm going to plot our eigenvectors on this particular model, and actually the ones I want to look at of interest the most are on this panel here. So we're going to isolate that panel, and then plot our eigenmodes just on that one panel. And so we can see there that we have we kind of have quite a low mode on that panel there. If I play that mode, that's for the whole. So if we move the modes to one of the higher modes here, we can see that we have some mode shapes on this particular panel. If I just scale it up a little bit. That might be a mode shape that might be causing you some concern, and you may want to stiffen that panel up by using some of these swaging features that already exist in the panel. So if we go back to our HyperMesh window again and bring up that panel within the HyperMesh window. This is the panel within HyperMesh, and what we're interested now to do is to replicate a feature of those swaging patterns to, let's say, a couple of other positions down below here, just to provide some extra stiffness for that panel. So we click on the replicate icon here, and we choose the elements that define the features that we want to actually replicate. So we can just simply draw a box around these swage here and this swage here. And then we say that we want to move that feature. We can click on the arrow here to use a drop down, or we can use a specific number if we know what that particular number needs to be. And we can position that panel, the swaging, wherever we want. And then once we've got a position where we want, we simply click replicate, and HyperMesh will now remesh and tie in that feature to the existing mesh, and also take care of any connectivity on that around those elements, which is the reason why we get some distortion around there of those elements, because there's some RB3 connections in there. But that effectively allows you to quickly replicate features that are existing within your mesh without the need to bring in some new CAD. And you can do some quick design studies in with that. So there we have a couple of options within the HyperWorks tools that allow you to change your mesh without creating any new geometry and explore some design changes within the finite element model itself. Thank you for listening.